Hi, and welcome back to, I think, the 7th, 8th episode of this tutorial on how to build a Cardano stake pool with the Raspberry Pi. This is Giovanni, also known as Crypto Joe 101, and today we will finally create the keys and the certificates to launch your Cardano stake pool. And before starting, I just want to show the project that we are following. I think that you may all have heard the news that I quit my job, and somewhere around here there is going to be like the link to the video where I did that. So I'm currently unemployed. So if you want to support me, you can do it in many ways. You can offer me a coffee from the GitHub project that we're using to do these tutorials, or down below there is a link to my Cardano wallet. So if you feel to make a donation, please do so. I also want to like to remind you that I'm a Cardano stake pool operator. My pool is called Easy1. We have a website. I have a website. It's called the easystaking.org. So feel free to check that out and delegate if you want. So without further ado, let's go straight into the today's tutorial. There are a series of 4 notes or disclaimers at the beginning of this, so I just want to spend a couple of minutes talking about this because these are extremely important. So first of all, I heard the feedback from the community, and a couple of people have raised the problem that the previous version of the Cardano node container was running with root permission, and that's indeed something that I never really liked. So in this couple of weeks that I've been off and I haven't made much content, I've decided to fix this thing. So I have released the new Docker files with which you can now build and run the Cardano node in a non-root way. Into the actually I'm gonna show you straight away now. Run node as user. So if you by any chance find any issue that all of a sudden the Cardano node doesn't start anymore, or there is like a permission issue, go back to the root of the project and check out the run node as user. I won't make an episode on this one because the explanation is it's very simple. It's very straightforward. Sorry, I've lost the. There we go. It's black on black. I've lost the documentation. There we go. The documentation is very short. It's just a couple of operations. They're very safe and quick to run. You should be able to do this yourself. But let's go back to the pool keys. Second thing, I just want to make you aware that starting from now, if you're doing this with testnet, it's not a big deal. But if you're planning to really do this on mainnet, we will now start to deal with real ADA, and we will have to create manually managed wallet and keys and secrets and certificates. And this can be either both overwhelming, complicated, and is prone to issues like losing keys, getting hacked, and all these kind of things. While I do recommend this as an exercise, educational exercise for testnet, if you don't feel confident and if you don't feel sure about what you're doing, please do not go ahead and do this on mainnet, because as the point tray says, I take absolutely no responsibility over your lost ADA or keys, and neither damage that you may cause to your hardware, your Raspberry Pi or your RSD while following this tutorial. This is completely an educational exercise that I'm doing, so everything is at your own risk. Feel free to contact me if you have questions about this one, but please be careful what you do, as I have many years of experience in this field, and sometimes I feel these things are complicated for me, as it is for everyone. So if you're less experienced, be extremely careful and only do things that you are confident and comfortable about. And then, last but not the least, there is one point that I have to raise, and that's the following one. All these tutorials, among these tutorials, I'm going to be covering how to set up the Pi and the stake pool and all the other things. But there is one area that I won't be able to discuss because this is going to be extremely different for each and every one of you. And this is basically the configuration of either the static or dynamic IP address. So I will probably do a different lesson on this one just to explain how to try to deal with this thing, but I will not in any way try to resolve this in a generic way, as there isn't a generalized way. So the way the different stake pool talk to each other is via relays. In this tutorial we haven't covered the relays, but we are doing relays, a block producing node in just one node, and we need the node to talk to each other. And they do this by setting up IP addresses or DNS names. We will see how and where we will have to configure this thing, but I will not go into details of how you can do this. In a different doc, I may give a couple of pointers where to go and look, but again, I will not provide any tutorial about that. So there are lots of sources out there. I may try to link all together. So I wish you all best luck. Join my Telegram, English-speaking or Italian-speaking Telegram if you want to raise questions or share your story on how to do this. Feel free to announce this project, issuing your pull requests based on your experience. If I have enough pull requests, I may try to gather how different people around the globe have solved this problem. But now it's the moment to start. So this part of the process is about setting up the pool. It used to be extremely painful back in the days. The official Cardano documentation are absolutely fantastic and really well written, but the steps, there are lots of steps, very manual, and some of them are time critical. So you have to, because whenever you sign a transaction, you only say this transaction is valid for a number of slots. So if by any chance you're too slow in signing the transaction and submitting the transaction, you actually will have to start back from scratch. And like at the beginning, this was, I decided to go down the path because I really wanted to understand what was going on. For simplicity and brevity, we will not go down that route, but we will be using the scripts from Marting, that is the stake pool operator of the ATADA stake pool. This is the project that definitely I'm going to be linking. It's both linked into the documentation as well as the video description. So you can find additional information here. And if you want, you can connect with him. There is an email, there is an home page, and I bet there is also a Telegram channel. So if you have any questions, just like reach out to him. Or read even the documentation of the same project. So right, here there is the address for donations. So if you feel to buy me a coffee in ADA, it's really very much appreciated. So without further ado, let's get the party started. So I just logged into my Raspberry Pis. I still have my Cardano testnet running. Let's see what's going on and if this bad boy is still going. Let's see a few seconds and see if there is a new tip. We're waiting for the next block. I bet you this is gonna come. There we go. Everything is working. So the way you can check this one is basically you know that you're on the latest block by just copying this the ID of this block, and then you can go on Cardano testnet, Cardano Explorer testnet IOHK. I'll put a link to this one as well. This is basically a blockchain explorer where you can put pretty much anything in here, and then it'll tell you. I'll try to find references to this. And in this case, this is a block that was literally minted on the 4th of May, that is today at 8:09. Perfect. So the time is matching. So let's go back to the docs and start following the steps. So the first thing is to ensure that you're on the latest, greatest version of the project. We just copy Ctrl+C to get out, and then rebase. There were a couple of updates. So this is done, and now we have to build the ATADA scripts. So I originally started to go down a different path and try to run those ATADA scripts on the Raspberry Pis, but I eventually very quickly realized that the amount of dependencies to run those scripts was really, really high. So I decided to just go down the path of building yet another Docker container. This is the reason why also a little bit of delay, because it was a little bit cumbersome, but got done at the end of it. So we just go down this path. There is a nice script doing this. For me, it's going to be extremely fast because I've actually already tested this one. For you, it's going to take like maybe 10-15 minutes. But once it's complete, happy days. Right, so we now have the scripts ready, and we have to start to prepare the keys folder. So here it begins with the risky stuff. So first of all, because we are running everything on the Raspberry Pi, we will create certificates and keys on the Raspberry Pi. But listen very carefully. After this last session and then with the next one that we're going to be starting, the block producing node, what you have to do is take those keys and remove them from the Raspberry Pis and put them somewhere else. You can put it on an SSD, on a USB stick. You can put them into the cloud, on Google Drive. There are lots of password manager applications that also support files or keys or certificates. Please think about a solution like this one. Alternatively, you can use also Ledger or the Trezor to manage those keys. It's really up to you. It's not up to me to tell you how to manage those keys because I don't want to be in any way responsible. So completely at your own risk, do your own research. For testnet, if you're spinning a testnet pool, this is more than enough. You can leave your certificate there because those are not real ADA. So a hacker will just steal your fake ADA or test ADA, so it's not really a big deal. But if you go down the route of my mainnet, you have to be careful and you have to do your own research on how to manage those keys. So for simplicity, I decided just to go to create a .keys folder into your home and then testnet for testnet. You can do exactly the same for mainnet, but once again, you create the keys for mainnet. Please remember to remove them from here, except the 3 keys and certificates that I will show you later on, but so that you know what I'm talking about. So the folder has been created. Let's do an ls-lart, and the .keys folder is here. Yes, we change the directory into it, and there is the testnet, and testnet is currently empty. Fantastic. So now we're ready to run the ATADA container. Basically, what we are going to do now, actually, I'm gonna show this thing into the a different folder. So let's just spend 2 seconds. First of all, you need to ensure, before I go on, you need to ensure that your Cardano node is running. If your Cardano node testnet is not running, just go back to the previous lesson tutorials, find the line where you were starting the node and start it. Because the scripts will need to talk to the Cardano node, and I'll show you where. So there is a folder called ATADA Scripts, where there is the Docker file to which we are not interested. The build will just executed, and there is the run. So the run is doing nothing else than basically starting the container that is here. Is also taking in account the node version and the architecture. So technically, if you want to do this on your own laptop, this is going to work as well. But then it's doing another couple of important bits. First one is mounting the folder of the keys into the container so that we can manage the keys from within the container, but the keys are on the Raspberry Pi, and this is paramount importance. The second thing is that we are mounting also the folder where the Cardano node is downloading the blockchain. We do not need the blockchain, but we do need the socket where the Cardano node is listening for connections. Why is that? During the registration process of our keys, we will have to submit transactions. So we will need to interact with the blockchain. And in order to do so, we need a running node, either being a relay node or a block producing node, but the relay node is perfect because it's like a full node. And this node is capable of accepting transactions. We will have to pay fees, we will have to make a deposit, we will have to send or receive ADA, so we need to interact with the blockchain. So this is exactly what this Docker is running, the Docker container is doing. Talking to the blockchain as well as interacting with the folder where we have the keys. So now that we know that, let's start it. It's going to take a couple of seconds and we're finally into the the container. As you can see, the user here is Cardano, is not root anymore. So happy days. And also another thing, sorry, I'm gonna go back to this one in a second. If you go on, I can't remember which one was that. Yes, Cardano node. I have a testnet and testnet backup, but if you go on testnet, you can see now that all the files are owned by Ubuntu, while before that patch that I showed you earlier on, everything was owned by root. And this one was a big deal, as it was not ideal. This is node.socket, is basically the socket that I was talking to you earlier on, and the ATADA script will connect to this one thing to interact with the blockchain, so that you know all the moving parts, where they are and how they're used. Right, let's copy the command again. And we are back into our container. So remember to issue cd so that we go into the folder. Now forget that a couple of folders here are marked as root, because only the ATADA folder is marked as root, but script and keys are owned by Cardano. So scripts is where the ATADA scripts are, I think. Yes. There we go. And then the keys folder is where your keys are or will be. So in this case should still be empty. Fantastic. And then if I go on ATADA, this is the folder where there are a couple of helper things that we will require. So let's go back to the documentation. So what we have to do now is that, because those ATADA scripts, despite being, those ATADA scripts are exactly the same for testnet or mainnet, but there are some configurations that are different. So because I didn't want to do two different containers, one only for mainnet and one for testnet, excuse me, I decided to just do one container. Then whenever you initialize the container, you start the container, you just have to do like a 1 second initialization, so that all the relevant files are set up and moved into the correct place. So all that we have to do is to run this command. And this is super fast. And the next thing that we have to do, as per the documentation, is this last one line that has been printed. You have to copy it, paste it, and execute it. What's happening here is basically we are updating our path, and we are basically adding this home Cardano script Cardano testnet to our path. This is gonna basically give us easy access to the ATADA script that are the one that I'm showing to you now. Right? If we didn't do the previous step, we couldn't do this, and it means that it's not. This is really handy, because it makes our life much easier and faster to call these scripts in a different folder. Right, we are actually finally ready to start to create our certificate. So first of all, I just want to say that I'm extremely excited of the fact that only last week, it was the famous Africa special. It was April 28th or 29th. And Cardano has finally announced their partnership with the Ministry of Education in Ethiopia. So in honor of this event, I will be calling our stake pool Afric. I just can do 5 letters and not 6. Excuse me. So I'm gonna just ditch the last A. And now we basically are ready to start this thing. Let's go into our keys folder. Currently empty, and now we have to start to generate different keys. So all the scripts are numbered, and we basically have to go all the way through from 02 to 06, I guess. So the first step is to create payment addresses. The ATADA scripts, they support multiple ways, so we're gonna be doing CLI, but if you want to create hardware wallet, there is an option here. So let's just show you the different options. So if you want to know how a script works, you just call it, and then it gives you a warning or a way of using it. As you can see here, it's basically telling you that this is the script, then you need to an address name, and then what type of key you want to create. We're going for the CLI, that is the vanilla version, and then there is hardware as well. So basically here you can use, as is written here, Ledger or Trace or hardware wallet. I haven't tested this one yet. I'll definitely do this myself, as I have a Ledger, and it's really nice to have a backup of those keys. So it may be worth for you to experiment. For simplicity, because I don't have a key handy, and the result is going to be exactly the same. I'm going to just run the CLI. It is very, very fast. If we do ls-lart, we see that there are now 3 files, Africa, Africa vkey, Africa ski, and Africa address. Vkey stands for verification key, skey stands for signature key, and address is the address. So this is your wallet. We'll actually use this one soon to get funds from the faucet. Vkey can be shared, skey can't be shared, because this is basically your signature key with which you sign transaction. In general, just don't share anything with anyone and you'll be fine. Just your address is fine if you want to receive funds. So first step done. Let's quickly go through all the other ones. Staking files. So there are different certificates. There are different addresses and certificates for normal ADA and for staking addresses. It's 2 different sets, and this command we just executed is the one to generate the staking key. Now, note the CLI param pass to the ATADA script can be replaced with other parameters that allow you to use hardware wallets. I just said this one. We now need to transfer we need to start to submit transaction, and because we need transaction, we need, in order to do transaction, we need the money. So what we're gonna do is to get $100 or 100 fake ADA from the faucet. So what I'm gonna be doing is to get the address that I just showed you earlier on. We're gonna take this one, we're gonna go to the faucet, hoping that it loads. There we go. And then into this drop down, we ask for there we go, sorry. Then we specify that we are not a robot. And then we request funds. You're only allowed to do this one once per day. So I really hope I will not need to do this one again, or we will be screwed. I just received an error at Chrome quit. I'll be back in a second. So Chrome has finally restarted, so we can resume the recording. Sorry about that. So we left that we were on the faucet, and we just entered the our address here, and then let's see now if we have received the funds. So it passed about an hour since the Chrome reboot. So in my case, I think the funds have arrived, but in your case, you may need to wait a couple of minutes. Testnet is not as fast as my mainnet, so you may need to wait a minute or 2. In order to do so, there is a command from the ATADA Scripts. You can run. Actually, I'm gonna show you. So if you press 0. And then tab, it's gonna tell you like which are the possible scripts, and if you start with 1, there are more. So I would recommend to test, for instance, the query address. That is gonna be basically that you can use to query how many ADA and native assets are on an address. In this case, you can pass either the name of the file where the assets are, where the funds are. So in this case, it's gonna be Africa payment. You just have to write those 2 little words with a dot in the middle, and this is gonna basically tell you the amount. So let's try 0 _ query address, and I'm gonna write Africa payment. Go like this, and then a couple of seconds, and then you see that there are like 1,000 Lovelaces. Fantastic. In case you can't find anything, the address does not exist, or whichever error, just wait a little bit and come back in 5 minutes, a couple of minutes, because testnet could be a little bit slower. Back to the documents. Where were we? So we have generated the stack address, we have transferred with the faucet, we have gotten the ADA, and here is explained also how to check the thing, and now it's time to register the staking address. So basically what we do here is the staking address at the moment only exists in our keys repo. We want to register it. So what we do, 03b. Again, if you want to know what the command is doing, just do 03b It's going to tell you a number of things: stake address, base payment address. Stake address is the staking address from the file that is Africa staking, and then the base payment address that is basically where the funds are. So we're going to basically write Africa staking Africa payment. And then, of course, this is going to show us like a preview of what's going to happen. It says, does it look all good to you? And you say yes. And then the payment is going to be done. And you need a couple of seconds to get these transactions done as well. So for instance, we want to check that the staking address has been registered correctly. There is this other command. And the staking address is already on the chain. So happy days. In this case, the block was registered straight away. Now we need to start generating the node keys. So you will see that there is now Africa node, vkey, ski, and counter. We need to generate the VRF key. This is like a very important key. This is used to find when the slot is the slot leader. And then we need the KES key. These are like key KES keys. This is used for these are rotating keys, and basically they need to be rotated from time to time, so that if someone steals your keys, they will only be able to run the pool on in your place for a limited amount of time, or unless you renew your keys, in which case the latest is the winner key. So it's a good thing. Also, this case is very fast, and you can see that now the new keys are being generated. VRF is here, KES keys. They are numbered because they're going to be basically incrementing, and the counter is basically saying which version of the keys is currently active. If I generate the keys again, this is going to go 001, and counter will be increased accordingly. So now there is a little bit operational chart. Sorry, this is still an easy one. So we just do this one as well, and this is the operational certificate that we need to run. So in this moment, I'll already tell you that the operational cert, the keys ski and the VRF ski, these are the three keys, the two keys and the certificate that needs to be installed on your block producing node. Everything else, once that you finish with this, they have to be moved and saved somewhere else and deleted. So you only need operational cert, the KES key and the VRF key. Everything else you need to delete everything. Well, not delete, like you have to save it and then after remove it from this thing. And now here begins like the only tricky part of the keys, of the generation of the certificate and the keys. So this generate stake pool certificate needs to be done twice. The first time the ATADA scripts are basically generating how to say, a placeholder, a template for the variables of your stake pool. You can customize as much as you want. We're going to be doing the bare minimum, and then you can just read the documentation and enhance them as much as you want. But what we have to do now is we have to generate the certificates, the stake pool certificates, as well as the metadata file. The metadata file is some additional information that you have to provide about your stake pool, like it could be the pledge, the variable fee, the static fee, the constant fee, as well as the IP address, or the DNS name at which your pool will basically be running, so that other nodes within the blockchain can actually connect to it. But without talking too much, let's start to get this thing checked. So we literally just only generated the Africa pool.json. So if we go Africa pool.json, this is basically a custom file that is ATADA Scripts related, that contains basically the information about your stake pool. As you can see, there are placeholders like owner name, who's the owner, and all yada yada yada, and all the other things. We're gonna go read through the documentation. I'm gonna be setting each one of them one by one. Some of those files and some of those properties then will actually generate an actual pool metadata file that is basically generated off of those ones, and then once that you upload that thing, we should be good to go. So let's go back to the documentation and see what the documentation says. Right, we've generated most of our keys, but now we need to customize the pool's characteristic. So edit the Africa pool JSON and let's put our favorite, with our favorite header, and let's put our own things. So owner name, because we are setting up a stake pool run by a single operator, we're gonna put his name, the name Africa, that is basically the root name of the pool. We put everything in this name that is Africa itself. So what we're gonna be, if you add more than one person pledging on the pool, you need to put more than one owner. But in this case, we only have one. So you move at the beginning of this one. If you're not expert in VI, you can use a CW. So you come here, press ESC, and then you go CW, and then it means change word, and then you can basically put Africa. So owner name is done. Pool rewards, Africa again. So where does this go? So basically here we are saying that the rewards generated by the pool, they have to go into this address. That is africa.staking.payment. Fine. So the pool pledge, because we are actually using the money from the faucet, that is 1,000, what we're going to be doing is that we're going to be putting even just simply 100 ADA, that is 100 million Lovelaces, so is 106 more zeros. Even in this case, to change word, we do 100 and then 1, 2, 3, 1, 2, 3, 6 more zeros. Pool cost, everybody has the bare minimum here. That is going to be 340, 1, 2, 3, 1, 2, 3. That is the 340 ADA. Pool margin, I'm going to leave it just 10% because this is, this one is a percentage and those two numbers is the percentage. If you want 100%, you put 1.0 or 0.10 means 10%. If you want 1%, is 0.01. In this case, we're happy with 10% because this is just like a testnet node. So relay type. In this case, I do not have a static IP address. I have a DNS name. So if you have a static IP address because you're running this thing, well, you can't run this thing because we're talking about Raspberry Pi, so you don't have cloud resources or whatever. If your internet provider has an static IP address, you can set this. You can set just like IP here. Sorry, IP here. And then put the IP address here that is like, I don't know, 123.123.123.123, or as in my case, is a DNS, and it's going to be DNS. With regards to this one here, I can't actually remember my DNS, so I will be back in a second. And we're back. So the DNS name is going to be this one. So relays testnet 2, I have to change the name to 2. And the port number is 30,002. So the DNS name is basically the DNS, it's going to be resolved into the IP address, and then the port number is the port number that is basically open on your router. So this is something that you will have to be careful about, because if you're running this thing at home, I guess you have like an internet connection, we have a router or something, you will have an incoming connection. So you need to find a DNS, DNS, dynamic DNS provider that's going to basically set up a DNS name based on your IP address and keep that updated. And then you need also to open a port number. This is basically the port number that you will have to configure on your router, so that connections coming from the outside world on this port number will have to be routed on the same port number, but on the IP address of your Raspberry Pi. Again, I can't help with this one because there are so many different routers in the world. Unfortunately, I will have to leave you alone with this one. But my configuration is done in this way. So pool meta name. This is basically the name that you want to give to my to your staking pool. So I'm gonna call this Viva. I'm gonna use Italian. That is Viva l'Africa. That is basically is like Yugo Africa, or like a nice thing about Africa. Cardano testnet pool for Africa. The ticker is like the 5 digits, 5 letters. it's gonna be Afric, as I said earlier on. And this one is, I'm just gonna put my Twitter profile. I don't care. We just need an URL address here. Let me just put this one. And then pool metadata URL. Now for this one we have to be a little bit careful because this needs to be done in 2 different steps. So at the moment we are happy with this configuration. What we need to do now, basically, this is like a little bit of a chicken and egg type of thing, because I want to use gists to public the metadata, but I will not know the URL until I generate the file. So what I'm gonna do is I'm just gonna basically leave the pool metadata URL as is. That is wrong, of course, but I will then let the ATADA script generate the metadata file for me. Then I'll take that one, I'll put it on the GitHub, and then I'll get that URL and I will update the document and regenerate everything from scratch again. So what I'm gonna do right now is just save and quit. The documentation says that I have to basically generate. We have to re-execute the generate stakepool certificate. This time it will detect that something has already been done. So after the Africa pool, it will actually generate more things like the pool certificate and the pool JSON. Sorry, the metadata JSON that is actually now cut Africa metadata JSON is basically what we just created. So what I have to do is just copy this one, and don't forget to, instead of stopping here, just go all the way down, because you need basically that one last new line, because otherwise the hash of the file will be different. So let's go on Git, and then simply from GitHub you can create a new gist. I don't know what the correct name is, but we go here and we go like new gist or gist, and then this is Africa testnet metadata.json, and what we do, oops, Africa testnet metadata.json. As you can see, there is a new line here, and this one, what was this one again? Gist description. Testnet metadata file for Afric pool. Create. No, this must be public. That's fantastic. And now we have to go raw, because this is the raw file and not the page in GitHub. Otherwise, this is going to be yet another reason for issues. Then I think it's git.io. Is this for shortening? Yes. And then we put that URL here, and then we shorten it. So basically, this is now the URL that we have to put back into this one. The only thing is that if you try now to do vi africa pool.json, it's gonna tell you that it is read-only, you see, down here. So what you have to do is chmod plus read-write africa pool.json. Oops, chmod. And we can now change this one. As you can see, now the metadata URL needs to be changed. Oopsie daisy, oopsie daisy. I need this thing again. And this should basically do it. I will do this one last one time, just to be sure that everything is in the right spot. And now what we have to do is basically ensure that whatever we have uploaded is actually has the same hash. So if you check into the documentation, basically what it says here is that now you can validate that the content of metadata file and the URL that we have actually entered contain exactly the same stuff. So what we're going to do is we're going to be downloading our metadata as we put them on GitHub, and we will test that the hash of this file is exactly the same hash that is into the metadata itself, the metadata certificate. So cat Africa pool.json. You can see that here there is a pool meta hash. So what we have to do is download the file and check that the result is exactly the same as this one. So what we're going to be doing, this is exactly what it is written here, core-L-O, and then this is our file, and then the URL. So we go like core-L-O, what was that? Validation metadata.json, and then this is the URL. So cat validation metadata, this is exactly what we were expecting. So then we run this one, and we see that this line is exactly matching the pool meta hash here. So we have the correct metadata hash. If these two guys are different, your stake pool will not be visible on either in testnet or in mainnet. And so people cannot delegate to you. You will only delegate to yourself. I'm actually not even sure if your pool will be able to mint. I think it will, but it won't be visible. And so you will never receive more delegations. Anyway, another step is done. So let's continue. We have to now, we've already run this one too many times. The next step is generate the delegation certificate. This is very simple as well. Just run it and we're okay. And then we have now to register the stake pool certificate. And this is going to ask us, it's going to check for the ticker. The ticker is everything okay. And then it says, do you want to pay? And we say, yes, we want to pay. Just ignore the highlight. I think this is just found the matching from before. So we are now registering our pool. As you can see, we have to pay 500 ADA because there is a deposit of 500 ADA. And whenever you register a new stake pool, these 500 ADA are not lost. You will get them back whenever you register the pool. So this is just good to know. And then, yeah, everything else looks good. So we press yes, and we let the transaction to be generated. The one last thing that is missing is the registered delegation certificate. This is basically you're saying that you're delegating to your own pool, and this is basically based on the 100 ADA that you we just announced. So we go this way. It's going to ask us for another. Okay, now there is something that we have to be careful about. This operation may actually fail because the previous operation of the deposit hasn't gone in yet, so there are still the 997 ADA. So let's see what happens. In fact, there is an error. The ledger state is inconsistent. So basically what we have to do is we have to wait for the previous payment to go in. So query address, what's it called again? Africa payment. You see, it just literally just went down. It was a 997 just a couple of seconds ago. You see? Basically what happens is that the transaction was accepted by the blockchain but wasn't registered yet. So basically there wasn't a block generated with this thing. And so we were trying to do the famous double spend. But of course the blockchain detects it and it says, yeah, hang on a second now. There is another transaction from the same wallet. And the numbers don't add up. So what are you trying to do? So the payment was refused. So we just waited for the bunch of seconds. We tested again, and then we saw that the balance has gone down. So when I go like this again and I press yes, I do expect this thing to finish properly, and there we go. So technically we are done. The next step would basically be use those certificates. Your pool is registered and is up and running. Well, it's registered, it's not up and running yet. we need to complete the configuration, and we just need to run the stop our node, the relay node, and start it in block producing node, and then basically we will be able to start minting transactions. There is no problem in leaving the things as they are, because at the moment there is only 100 data delegated to this pool, so the chance of this block actually being assigned the slot is basically 0. So and the next step, in the next couple of days, I'm going to prepare the next step of the tutorial where we're going to shut down the relay node and start in the block producing node with the certificates. And then, in the meantime, I'm going to download the Daedalus wallet for testnet, so you can download this one as well. I'll put everything into the link so that you can basically ask for money and actually delegate to your own pool in testnet. And in the space of a couple of weeks, you will start to see how your pool in testnet is actually generating transaction. And I want to say thank you if you got so far. I wish you all the best and all best luck. I encourage you to go through the document of the ATADA Scripts if you have any issues. The documentation is beautiful. If you're running this thing against testnet, is completely fine to make mistakes. You're not losing real ADA, and it's really educational. If you get stuck though on any of the points, feel free to join my Telegram channel. There is both an English and Italian one. In Italian one, we only discuss generating things. In the English one, we do the more technical stuff. So I encourage you, even if you're Italian, to join the English one, because that's where we help each other on this journey. So thank you again. I just want to remind you that if you like the content, if you want to support me, please consider either make a donation with coffee on GitHub, or delegating to my stake pool, or additionally you can even donate ADA to the address that is in the GitHub repo. Thank you very much. In the meantime, I hope that you're seeing like a couple of links or other videos. Don't forget to subscribe, and thank you very much, and I'll chat to you later. Bye.